Today we're going to talk about similar triangles. Triangles are similar if they're the same shape but not necessarily the same size. So let's give you an example of this. So this is a nice little web page that I have found, and we're going to make sure all the triangles appear. And these two triangles are considered to be similar. In other words, they're the same shape, but not necessarily the same size. Notice that we say that this angle over here has a single line through it. It means it's equal to this angle over here. And this angle here is equal to this angle here. And finally, we have this angle here equal to this one here. So first thing you should know about triangles that are similar is, besides the fact that they have the same shape but not necessarily the same size, the corresponding angles are equal. Now, as I take the corner of one, let me just close that ink layer so I could do this. And if you notice, as I take the corner of one, they're both changing. And even though the lengths of the sides are different, they're still maintaining the same shape. And by the way, the same angles are still equal to each other. We're not changing the corresponding angles. The corresponding angles are still equal, and therefore these triangles both have the same shape. No matter where I stop it, the two triangles have the same shape. Now the two triangles have the same shape, two triangles have the same shape, two triangles have the same shape, and all the corresponding angles are still equal. The other thing that we should know about similar triangles is that the corresponding sides are in proportion. So let's just look at, to see what that means, let's just look at one pair of sides here. Notice that this side here is 8.5, and that is half of the corresponding side there, 17. Now, if I were to distort, change the shape of this triangle, make them two new triangles, but have them both be similar, you'll see something that will stay the same. So let's do that. Notice, I should probably take this side, and notice that even though I'm, let's make this a nice even number here, 18, 19. So notice that this triangle is similar to the other one. This side is half of that side. And that's kind of what we mean by the corresponding sides in proportion. In this case, that's all true. You notice that this side here is half of this side. And finally, this side here, this 10.1 approximately is half of 20.3. So what we're trying to get at here is that two triangles are similar if they have the same shape, but not necessarily the same size, but they could have the same size. The corresponding angles are equal, and the corresponding sides are in proportion. In this case, all the sides of the corresponding sides of the small triangle are half of the corresponding sides of the large triangle. Let's look at some right triangles today and give another example of this. So going back to our original screen, we're just reiterating that the corresponding angles are equal, corresponding sides are in proportion. So in this case, we have two triangles. In this case, they're right triangles. They are similar, meaning the corresponding angles are equal, and the corresponding sides are in proportion. So we'll say that this angle and this angle are equal, and we'll say that this angle up here is equal to this angle up here, and of course the right angle is equal to the right angle in the other one. Now, the way to find the corresponding sides is by looking at the angles. So in the first triangle, we see that A is opposite the red angle, and A in the larger triangle is also opposite the red angle. Let's give these numbers. So let's call this, let's say this side is 3. And let's say this side, just to make life easier, let's double it. It doesn't have to be double, but I'll double it, make it 6. Okay? that would be the corresponding side because they're both opposite the same corresponding angle. In this case, the red angle. If we were to go to this side, let's say this one is 4, this side is 4, and if I'm making everything double, then this side would be, oops, I meant 8, not 5. So we'll write 8. And finally, if I say this hypotenuse here is 5, then its corresponding side is 10. So notice that the 4 is green opposite the green angle, and the corresponding side in the big triangle is the 8, which is opposite the green angle. And finally, the hypotenuse of the corresponding sides in the two triangles, so 5 in the small and 10 in the large. We could write some proportions. For example, what we would normally say would be 3 is to 6. Those are the corresponding sides, as 4 is to 8. That's another pair of corresponding sides, as 5 is to 10. So that's a proportion we could write, and that's why we say the corresponding sides are in proportion. In this particular instance, the larger triangle is twice as big as the smaller one. Okay, so let's do an example. Let's find another triangle. What I'm going to do is copy this triangle, and then I'm going to paste it. I'm going to take it over here, and we know they're exactly the same size and same shape, but I'm going to just make it bigger and bigger and bigger, but keep the corresponding sides in proportion, so it's still going to be a pair of similar triangles. And let's say I knew the sides of this triangle, small one, are 3, 4, and 5. We're picking that nice even numbers, whole numbers, to make life easier for you. And let's say I said to you, this side A was 12. And I said, find the other sides. Well, in order to do that, you would have to set up a proportion. So in our case, we look for a pair of corresponding sides. So we certainly know that 3 corresponds to the 12. Let's keep this color coded, and let's keep it red. So we'll do it in red. We know that 3 is to 12, because those are a pair of corresponding sides. And let's circle this one in blue. So as this 4, and we don't know what B is, but that's what we're trying to find out, is to B. So we know that 3 is to 12, as 4 is to B. Therefore, that's since there's similar triangles, corresponding sides are in proportion, and that's what this means. We certainly could solve this. Most of you know that you can cross multiply. So if we cross multiply, we get 3b equals 48. Divide by 3, divide by 3. And we get b is equal to 16. And so finally we figure out that side B is 16. And that's a way of finding a corresponding side in the triangles if you know that they're similar. In a similar way, we could find side C. Now you have a couple of options for side C. You do know that you could use the Pythagorean theorem. And if you know one side is 16, one side is 12, you can use Pythagorean theorem to get C. But since we're dealing with similar triangles, let's continue with that. So we will say this side is 5, and we're trying to find C. So we know that 5 is to C. And now let's just pick another pair, any pair of corresponding sides. Why don't we pick the 3 and the 12? So we know the 5 is to C, as 3 is to 12. And once again, you can cross multiply, and you get 3c is equal to 60. 5 times 12, divide by 3, divide by 3, and you get c is equal to 20. And there you go. And that is a way of finding the corresponding sides in similar triangles. So now it's your turn. So here's a problem. It says find the measure of side AB in triangle ABC. So we're looking for this side right here. If triangle ABC and triangle DEF are similar triangles. So what I want you to do is try to find side AB. And since we're at it, why don't you also, when you're finished, try to find side AC as well. So you're going to find side AC as well as side AB. Okay, good luck and see you again next time.